Now let's take a look on this problem. First of all, we can do the similar to the previous problem is to check the reference. And if you scroll around here, you can see that the problem is more similar to the figure over here, figure 29. So we can use the reference over here to draw the shear and bending moment diagram. First of all, I will draw the shape of that like this. So I can draw load diagram first. Now I know the load here is 300 pound over a foot, and from here to here is 20 feet. And then we have the shear diagram will look like this. Up here, down, up, down, here. And then I have the moment diagram will look like this. Yeah, this is low, shear, moment, pound, foot, pound. All right, so now we can calculate the value of that. We have the value of this one over here is V1. V1 will equal to 3 WL divided by 8. And V3 also equal to V1. So this one and this one just the same thing. Let's calculate that. So we have this one is 3WL divided by 8. And I know that W is 300. So 3 multiplied by 300 multiplied by L is 20 divided by 8. And now we have this one equal to 2250 pound. This one, because it's similar to equal to V3, so it's also equal to 2250. Now let's calculate the value of here and here. We have this value we equal to V2. This one also equal to V2. And V2 is also the V max is 5WL divided by 8. So this one we equal to 5WL divided by 8. And I'll just skip the step over here because it's very similar to this one. So I will just calculate over here on my calculator. Just plug in 5 multiplied by W is 300. Multiplied by L is 20 divided by 8. I will have that one is 3750 pound. And this one also 3750. Okay. So now let's calculate moment. For moment, we have this value over here and over here is equal to M2, and M2 will equal to 9WL squared divided by 128. So this one over here, 9WL squared divided by 128, and that will equal to A438 pound foot. Similar like that, this one also equal to A438. Okay. Now let's check the value over here. This value over here we equal to M1, and M1 we equal to WL square divided by 8. So we have WL square divided by 8 we equal to 15000 pound foot. Right? For question B, what is the Vmax? So look on the diagram over here. We can see that Vmax is 3750 pound. So Vmax is 3750 pound. And this one is at the middle of the whole beam over here, which means around here. So that is at 20 feet from the left. And I can say at 20 feet. Right? Now we check the Vmax, Mmax up positive Mmax. Mmax positive which means on the top, on above the beam. So the Mmax positive is A438. So this one will be A438 pound foot at. If we want to know where is the location of that, we need to check the reference. So from the reference over here, you can see that the Mmax will at 0.4215 L at 0.4215 L. That will equal to 0.4215 multiplied by L is 20. I will have that one is 8.43 feet. Now let's check the Mmax negative. Negative which means below the beam. That is this one. This one is actually negative. So Mmax negative is 15,000 pound multiplied by foot. So we have this one is 15,000 pound foot. And at where? This one is at the middle of the beam. So it's at 20 feet. So you can see that normally for the shear, we just care about the magnitude of that. So which means we just care about the value of that. We don't care that one is positive or negative. However, for the Mmax, we care about the size of that. Later on, when we discuss about reinforced steel concrete, you're gonna learn more about this one. But basically, if you have positive, you need to put the rebar on the top of the beam. The rebar on the bottom of the beam. And if you have the Mmax negative, then you put the rebar on the top of the beam. That one is very important. So for now, just keep in mind how to recognize Mmax positive and Mmax negative and how to calculate it.